and we can go to the next speaker. The next speaker is Pedro Ferreira. Pedro is a student in computer engineering at the Federal University of Rio Grande, Brazil. Since 2023, he has been involved in research activities focused on internet infrastructure, particularly BGP routing, regional internet registry, routing policy, and technical aspects of internet governance. And today, Pedro will present tracking visibility gaps in allocated internet resources. Pedro, the stage is yours.
Boa tarde a todos. Thank you, Massimo, for your introduction.
Good afternoon, everybody. Thank you, Massimo, for your introduction. I'm going to present my last paper, Tracking Visibility Gaps in Allocated Internet Resources, together with Professor Pedro Marcos. We know that the internet resources such as the IP addresses and the autonomous numbers, system numbers are essential for network operations, and their management is handled by the regional internet registries, the IRRs. Today we have allocated between the 5 RIRs, we have 118,000 ASNs, 3.7 billion V4 addresses, and 38 times 10 to the 24th IPv6 addresses. The objective of this work is to investigate which are not visible in the routing table and to see the resources that are behind. Here I bring a geographic representation highlighting LACNIC in Latin America and the Caribbean. Although the implementation of IPv6 is growing, the IPv4 address space and the ASNs remains to be fundamental in for the operations of the networks, and many of them are not visible in the routing tables. Understanding who those resources belong to and why they are not visible is interesting, so we can understand the infrastructure of the internet as a whole. So here I divide our data sources in between allocation files and routing data. And the allocation files are those that are made available by the IRRs that are gathered every day. And the routing data, we use all the tools of route views, PCH, from 1999 to 2025. And the most recent one was in October the 1st, 2025. So what is the history? In LACNIC 23, we debated how long it takes for an IPv4 prefix allocation to become fully visible in the subnetworks. And here we saw that the average is 81% of the IPv4 assignments that become visible after the allocation, and LACNIC has a 92%. And we see that for the internet, 34% of those allocations are done fully announced in the routing table after 1 year, and LACNIC 24%. What are the resources? We see that the resources take some time to become visible. And the question is whether some RIRs require them to be visible within a certain period after allocation. And the answer is yes, some RIRs in specific cases, and LACNIC is the exception. LACNIC requires a deadline for all allocations to be announced, not just in specific cases. There you have the policy. I won't read it. And we also debate resources that probably had an impact on the on LACNIC's policy, potentially, because there are some cases where the justification can be made. So in those cases, it wouldn't go against the policy. But we saw that 20% of the ASN allocations did not meet their deadline. 28% of IPv4 and more than half for IPv6. And we have the question of the allocated and not visible resources. How many and for how long are they not visible? Here you have a table with the type of resources. Almost 29% of the autonomous systems are not visible today. And when I say visible, it may be announcing a prefix only serving as a transit, not necessarily of origin, and 19% are not visible for at least 5 years, and about 15% not visible for at least 10 years, and 11% are never visible in our analysis. For that is with ASNs. For IPv4, I won't give all the details, but today 15% is not visible, and about 3% was never visible. And for IPv6, today 67% is not visible, and 54% was never visible.
The purpose of this study is that there are some non-visible resources, and in some cases potentially even conflicting with LACNIC policies. And what we tried to address here is to identify patterns among these non-visible resources, in addition to responding why these are not visible in the public internet. These are the results. Here we see that 500,000 V4 addresses, 26 times 10 to the 24th IPv6 addresses, and 34K ASNs are currently allocated but not visible in the public internet. So we will then examine how these were allocated in order to determine correlations. We saw resources that were involved in transfer processes to from one organization to others, other through the IPv4 waiting list between RIRs, legacy resources, and we deal with legacy resources as resources allocated prior to the beginning of the internet, in addition to other cases. Let us start with the region. Here we see in the x-axis the timeline from 1999 to 2025, and the other axis the visible ASNs in percentages of the allocated ASNs. ARIN is the region with less visible resources in percentage terms. Regarding the autonomous systems, in the case of IPv4, there is a similar graph. We see that ARIN is a region that is the least visible one. In the case of IPv6, the same graph also shows ARIN as a less visible region. Let us now have a look at transfers. This graph is somewhat more complex, and I will try to explain this. In the middle of the x-axis with numbers here, that is the transfer month of that resource. There we see the visibility of the resource prior to the transfer, 2 years prior and 2 years after the transfer. In the y-axis, we see the percentage of visible resources involved in the transfer. So we can see on the right side of the graph the visibility of these resources after 2 years following transfer. These are data for IPv4. Regarding the transfer resources following 2 years, 61% of visibility of the IPv4 addresses involved in transfers are still visible following 2 years versus 85% in the internet. So we see that there is a relationship that some are least visible in the routing tables. In the case of IPv6, we have similar percentages. For ASN, 64% of visibility is after 2 years compared to 72% of the general value. So the transferred resources show a higher tendency to remain non-visible when compared to IPv6. Now let us look at the waiting list. We have 3 RIRs with waiting lists for IPv4, ARIN, LACNIC, and RIPE. These are some of the statistics. LACNIC has a longer waiting list, about 1,600 days of waiting list and 1,700 requests, and it was the one that allocated the largest amount of resources through the wait list. We see that ARIN, the allocated resources through wait list, have 82% visibility. 78% versus the 82% of the general case. In the LACNIC, the waitlist is 93% versus 93% the general one. In the case of RIPE, it's 80% of visibility versus 86% of the general one. So while waitlist allocations account for only a small fraction of the overall allocated but not visible pool, they still remain a category with relatively low visibility, except for the case of LACNIC. Now let's just have a look at the legacy resources. In the early years of the internet in the 90s, the allocations made by IANA were very generous, very big for private organizations with less restrictive policies and contracts. As a result, the question raises regarding the resources allocated in those early days, and we're taking the year 2000s as a boundary between the legacy and more recent allocations. So, as a result, we have this table, the RIR column. We see the ASN legacy, the older ones. We have ARIN with resources allocated in the previous century. And then we have the ASN visibility, where the numbers outside the brackets are the legacy resources, and the ones in brackets is the visibility of the more recent resources. We can note that in the case of ARIN, 33% of the legacy resources are visible, whereas 65% of the more recent resources are visible, so the older resources are less visible. This is for IPv4. We have the line for ARIN and RIPE. They have a lot of the older resources in their pool. In the case of ARIN, more than half are v4 addresses assigned prior to the year 2000. The same thing occurs. 75% of the legacy resources is 75% compared to the 90% of the current ones. So there we now look at the visibility per region. ARIN was a less visible region. Much of this is due to the older resources that they have in the resource pool. This deals with other cases that go beyond the analyzed categories. There's still a significant amount of resources without visibility in the public internet. Very often these can be used internally with private or government networks where this announcement is not a requirement. Clear legitimate case is that of IXP peering LAN prefixes. These are the ones allocated internally at the traffic exchange points and are not announced intentionally. While some of these resources may be used internally, we must recall that there are many autonomous systems and address blocks foreseen for internal use in our RFCs. So maybe not all these cases of internal use can be justified. Then there are other cases, and this is a reflection. These resources may neither be public announced nor internally used, but instead they are maintained for speculation purposes, considering there is a secondary market for IPv4 transfers, including 6 feet ASNs for transfers and leasings. So if these resources are being used internally, how can we see these? To estimate this, to estimate how many non-visible addresses are used internally, we rely on CADA's ARC dataset. They run daily trace routes from vantage points globally distributed to all /24s that are advertised on the routing table. So for each /24 that we don't see on the routing table, we can check whether at least one of the addresses appears as a hop in a trace route measurement, even though this might not be the final destination. So this indicates that the address is being used internally. Our analysis shows that only 0.18% of the non-visible blocks appear as hops in the trace routes. So to sum up, a non-trivial share of internet resources remains non-visible in the global routing table, even though they are formally allocated. We see that allocated resources prior to the year 2000 have lower visibility compared to those allocated more recently. We see that transferred and waitlist resources tend to show lower visibility. This means that the specific allocation mechanisms may be disproportionate. They may disproportionately contribute to the non-visible pool. And regional differences are strongly tied to legacy holdings. ARIN holds a large volume of legacy resources for ASN, for IPv4.
Some resources may be used internally by governments, by governmental or private networks, and although there are blocks of networks and ASNs for internal use, maybe they are not always justified, and when checking with CAIDAS-ARC traceroute dataset, only 0.18% of the non-visible IPv4 24 appear as intermediate arms, suggesting that internal operation use is small. So now I'm ready to answer any questions you may have.
Pedro? Okay, I have a question for you. In IPv4, very large allocations at the beginning contributed to low visibility. In the case of IPv6, do you observe similar behavior?
Thank you, Elisa. Meu microfone. Thank you, Elisa. Sim, a gente identifica pelo menos um caso que gerou preocupação em fóruns da comunidade. É o caso de uma alocação de 1/16 de IPv6 alocado para uma rede financeira, um banco privado.
We identified almost one case. We saw it in a case in a proposal, a policy proposal in 2024, restricting the basic result for 2026. The policy didn't go any further, but I'm sure that there's a similar behavior, and the concern is there.